So this is a example of the digital LED strip that I have, and how amazingly bright it gets when run at 70% brightness. These are most of the patterns that it's doing are at 50% brightness, like the rainbow fade here, for example. Again, this is 50% brightness, all running on an Arduino Uno and a converted PC power supply that is driving the 5-volt power rail for it. This is just a rainbow fade pattern that I modified to run this strip. The strip that I have is 30 LEDs per meter. This length that I'm running from here across my ceiling over to the window is 5 meters and runs at 9 amps under full load at white full brightness. So it's probably drawing between 2 and 3 amps with these patterns that I'm running. I have some battery packs coming in that will run this strip at 5 volts, so I can be mobile with these Arduinos, as well as some smaller Arduino boards, so that I'm not limited to the Arduino Uno that's sitting there on a breadboard, and it's kind of large and obnoxious, but this is a good example of the effects that are available to me. There's a red, a green, a blue, and a 75% white brightness LED color wipe. So that's what this is right now, 75% brightness. Crazy. And now it's back to 50% for these patterns. I'm going to play around and see what current draw is with all these patterns at 100% brightness, just to see what this crazy strip is capable of, because it's quite impressive actually. The camera makes it bloom really badly, but in person it's not super blinding like it is in the camera. And there's the laughter of my roommates. We're watching a movie or some sort of TV show right now. So yeah, this is what I've been working on and fighting with for the last couple of days, especially my days off. Soon, I don't know if you'll be able to see it, I'll be making this chip here on the end that's just kind of chilling by itself, which is an MSG EQ7 7-channel audio analyzation IC, work to control all these patterns that I have. There's also an Arduino library called the Fast LED Arduino library that I can't seem to get to compile properly, but when I do, it will be able to control the speed, the brightness, the color, and the basic response of these LEDs to music. Kind of like a music equalization, visualization chip. And it's this guy right here. I think these chips that I got were Chinese clones. So, yeah, I don't expect a whole lot of those. I do have some breadboard mountable standard DIN ICs that I'm going to play with in the next couple of days once I figure out the values of the resistors and the capacitors that I need to interface them to the Arduino. All this is operating on 5-volt logic along with a 5-volt power supply, so it makes it really easy to make battery packs for mobility and, being untethered. This strip here that I've got, I'm probably going to cut down into smaller pieces. However, my roommates have expressed interest in making something like this for the Christmas tree this coming Christmas, so this strip may actually get donated to that cause, and I have another strip that's got close to 5 meters left from the pieces I've cut from it for experimentation. The cool thing is, I don't know if I'll be able to zoom in on the particular LEDs here because they're bright as hell, but each one of them, if this pattern lets my camera compensate here, each one of these LEDs is special because it has the serial controller built into it. So it has a 5-volt line, a ground line, and a data in line. And the Arduino is driving the data in line. When the chips are initialized, they automatically, at full speed, pass a bit down from their input to their output, an address allocation. So the first chip, which is here, will go, "Hey guys, I'm chip number 0. And the chip here will go, "Hey guys, I'm chip number 2, because it goes, "There's a chip number 0 in front of me." And so on and so forth. So that's all transparent to the Arduino programming. And that's why they work the way they do, with these cool color wipes and patterns. I'm uploading this video on YouTube, and also going to link it on my Facebook page here for my friends to see. And when I figure all this stuff out and get all this working properly, I'm going to offer my services to install these in fursuits and costumes and whatnot, and hopefully have this MSG-EQ chip properly functioning so that I can then integrate that so that you can have a microphone or an audio input device, or even your cell phone and a Bluetooth speaker, for example, control all the fun patterns and color wipes and gradients and all that cool stuff on the fly, maybe with 1 or 2 buttons. But yeah, the strip right now that I got cost me about $25 for 5 meters, and the Arduino stuff is about $35 altogether. The MSG EQ adds another $15 to $20 onto that, so I'm probably going to be selling it as a package for about $150 for the code and programming and parts. So it'll be very, very, very competitive pricing. It's not going to be really like a whole lot of profit for me. So I think every 2 to 4 strips or kits that I sell with this, possibly with installation even, will allow me to buy another kit. So, at least in the start. Once I get this all wrapped up and finalized and everything, I'm going to have a finalized Arduino prototype with this MSG EQ chip on it, and all of that stuff integrated into a little tiny board that's the same width as this strip, so it'll bring the price down. But I figured I'd share with all of you guys, my friends and followers, since this is the kind of geeky stuff that I do when, you know, I don't have work and have my weekends and free time available to me, because I find it very fun. And my computer's here. I just dropped a flashlight, don't worry about that. With all my Arduino programs and testing code and all that stuff, and looking at other Arduino products to see if they'll fit the bill. But yeah, that's what we've got so far. Enjoy, this is pretty cool.